Okay, good morning everyone. Good morning folks. Let's start. My name is Hugo Gaggioni. I am the CTO for Sony Corporation in the US. I want to share with you some new technologies that we've been developing for the very high quality remote production, for live production. We call it ultra low latency transmission technologies. These are the topics I'll be covering fairly quickly. If you are interested in the slides, you give me a business card, I'll send you the slides so that you can read more peacefully later. It's a lot of slides. I'm going to give you a very quick presentation on the ultra low latency HEVC coding, some of the devices that finally we are now bringing into the market for live production. I'm going to give you a brief tutorial on 5G so that you get some idea of what 5G is all about. And I'm going to explain a very important a sport event that took place last week using this technology. Okay, our dream inside Sony is to be able to connect at very high levels of picture quality and ultra low latency many places in the ecosystem of production, whether it's from stadiums to trucks to the broadcast centers to cloud, so switchers that are based in the cloud. And latency, and there are three things that are always fighting each other. It's picture quality, ultra low latency, and data rates. And as you can see in this environment, the number one pain point is bandwidth. If you're talking about 4K, you're looking at almost 12 gigabits per second, uncompressed. If you're looking at 1080p, it's 3.2 gigabits per second. Therefore, even if we had the money to pay for that bandwidth, the telco services will not give you those channels on a spur of the moment. That bandwidth doesn't exist really at any moment. Then Sony has been searching for a bandwidth allocation, and we think that 1 gigabit per second is ubiquitous, it's very easy to obtain, it's very inexpensive, and we can get it anywhere. And we've been testing this in Asia and Europe and now in North America. Our goal is to be able to put over 10 cameras in 4K over 1 gigabit per second, or over 40 cameras in 1080p inside 1 gigabit per second. If you do the math, you realize that this requires some very unique compression technology. Today, at very high levels of picture quality, we are looking at JPEG XS, that you may know is the favorite standard for truck operations from stadiums to broadcast center, but it's intra-frame compression, intra-picture compression. Therefore, the data rates are very, very high. And on the other hand, we have something called HEVC, high efficiency video coding. It's the standard H.265, which is inter-frame compression, inter-picture compression, which produces spectacular picture, low data rate, but the latency is high. Then we have developed, Sony Corporation has developed a chip that is capable of handling 4 channels of 1080p, modifying the encoding side of HEVC. This is compliant to the standard of H.265, but the encoding side is very, very dramatically changed to produce latencies of less than 2 frames per second. This is less than 30 milliseconds encode and decode. Then here I'm comparing uncompressed 4K, which is close to 12 gig. JPEG XS, visually lossless, is about 2 gigabit per second. Very nice, it's also 1.2 gigabit per second. Look at the compression ratios are very small because it's intra-frame compression. We can achieve those picture qualities at compression ratios of 200 to 1. I can go down to 60 megabits per second and produce a spectacular 4K. I can go to 10 megabits per second and can do 1080p, very, very high picture quality, but with very low latency in encode and decode. In here, I'm showing some experiments, some testing that we've been doing. Other manufacturers are also using H.265 inside the SRT transport protocol. But notice the latency is too high for live production. You're looking at 44 frames per second, 44 frames of latency. That is unacceptable when you're trying to match shoulder mount cameras and studio cameras on a live production environment. Therefore, we are now very encouraged with this new development of our development of H.265. And this chip is now being deployed in a number of products that we've been showing experimentally, last 3 NAVs. One is our, what we call a LAN WAN gateway device that I'll explain in a minute. At this NAV, we show a wireless contribution unit that attaches to cameras. And our sister company, Nevion, is now also about to launch our Virtuoso. Is basically a software-defined processor that will, we are now producing a card with this chip to be able to encode and decode ultra-low latency HEVC. All right, just a few words on this unit, the Media Edge processor, we call it the ME80. It has 2 chips inside. Well, also power supply, some other stuff. It's capable of handling 8 channels of 1080p or 2 channels of 4K. And what we announced at NAV is that each one of these HD channels will be able to accommodate 16 channels of audio. This is very important. Production companies have been asking us for 16 channels of audio per video signal. Therefore, this unit communicates to the LAN using a 10 gigabit SFP28 connection. Therefore, it's a 10 gigabit between unicast point-to-point communication. You can connect the video sources either using SDI or 2110. We can put 25 gigabit per second SFP connectors in the device. And then the data rate that we are recommending is, if you're doing 4K, between 60 and 100 megabit per second. Yes, we can go up to 200 megabit, but it's not necessary. 100 megabit is incredible. This is 422 10-bit. For HD, 1080p, we are recommending up to 35 megabit per second. We can do 1080i at 15, 12 megabit at very, very high picture quality. Also very important is this little thing over here, NMOS, Network Media Open Specification. This is the control protocol to be able to control these devices remotely using 2110 orchestrators. This is very important. Okay? All right, what can we do with this unit? We can send a channel from one location, from one truck to the broadcast center. I can send 4, I can decode 4. I can go SDI to 2110, 2110 to SDI. And the 2 use cases that we have been focusing is the use of these devices for remote production in stadiums in order to match studio cameras that traditionally have been using fiber between the stadium and the trucks, and the quality that we can get from shoulder mount cameragraphers. And this is very important use case. The other one is what Amazon, Netflix, everybody's asking, how to bring cinematography cameras from faraway locations back to the post-production at very high levels of picture quality. Therefore, in other words, at 24 frames per second operation. Okay, this is an interesting slide. Yes, we have studio cameras, and they are fiber to the truck or to the broadcast center. The magic number to be able to do switching between the shoulder mount cameras and the studio cameras is 100 milliseconds. If you exceed 100 milliseconds, yes, of course you can switch, but you will see the hit in the pictures between the camerographer and the studio feed. Then if you do it before, if you can do encode and decode and including the transmission on the 100 milliseconds, you can mix those signals perfectly in the video switcher during the production. All right, that's this guy. That is the ME80. The other unit that we introduced at NAB is this remote production unit. We call it the RPU7. This device has 1 chip. The other guy, 2 chips. This has 1 device that can do encode and decode. Therefore, this unit will do 1080i, 720, will do 4K, 1080p, but only 1 channel. And it will support up to 16 channels of video. Then this unit is designed to be connected to cameras, shoulder mount cameras, or handy cameras, or cinematographic cameras. And you'll see this is the unit that's going to connect to 5G for communication. There's again the data rates that we're recommending for 4K between 35 to 200 megabits, for HD 12 to 100 megabits. And this unit will also be able to receive control data from remote location to grade the cameras live. Therefore, you can have the camerographer, and the trucks are actually controlling the cameras by control data systems transmitted over the 5G network. Here you see some of the adapters that we have to connect this compressor to the camera. Okay. Notice the experiments that we have been doing during the last 2 years have been using a phone to connect to 5G. Therefore, the SDI from the camera connects to the compressor. The compressor has a USB-C connector. The USB-C connector connects to the phone. The phone connects to 5G. But at this NAB, we show something very special I'm going to show you in a minute. And also we announced that the ME80 will be able to decompress, receive 2 channels of the cameras on the fly. Okay? All right, with that, I'm going to give you a very quick tutorial on 5G. What is 5G? 5G has 2 bands all around the world. One is, we call it the sub-6. It goes from 450 megahertz to 6 gigahertz. And the other one is called the millimeter band, which goes from 24 gigahertz to 100 gigahertz. Okay? The sub-6 has a very far-reaching spectrum. You can reach up to 30 kilometers in reach. The speed is faster than the 4G in terms of data transfer, but is slower than the millimeter wave. The millimeter wave is insane in the speed of transmission. But millimeter wave is almost direct line of sight. It has a very short range of transmission, up to about 2 kilometers maximum. And also it's very fragile because you are looking at 24, 38, 50 gigahertz. Therefore, if you can block the signal with your hand, with the wall, with a tree, you're going to drop frames. You're going to drop the transmission. Therefore, most people are using the sub-6 for a 5G transmission because sub-6 can go through walls, through bodies. And the sub-6 uses macro cells for the base stations receiving the signals. Millimeter wave is mostly for cities when you have direct line of sight between the user and antennas in the buildings. Then these are the different types of base stations that we use for large cells or small cells. And there's another element that is important is something called NSA, non-standalone, and standalone. Then if you start experimenting with this and you're talking to T-Mobile or Verizon or AT&T, they're going to ask you this question: do you want NSA or you want SA? SA is a standalone, meaning the infrastructure is completely 5G. Non-standalone is to use a 4G core infrastructure and only the transmitting devices will be 5G. The speeds are lower, the transmission reach is lower, but it's easier to implement, less expensive to implement in the market. Therefore, in the US, we've been trying something called the NSA, non-standalone implementation, using 4G core of transmission. The other thing that we need to consider is something called slicing. We're going to slice, we're going to partition the bandwidth of transmission. And this is necessary in order to avoid congestion and interference between the channels going over the 5G. Therefore, if you talk to any of the telephone carriers, they will ask you, do you want a private gateway? You want a private 5G? Or you want a public 5G? Okay? And this is becoming also a little bit politicized because now that we have this net neutrality situation, the FCC may ask you, well, you want to buy a specific channel of communication from a given carrier. Why? Why don't you use the public environment? Then this is still, from a business regulation viewpoint, a little bit complex. Okay? All right, we've been testing this, and in February, we went to the Mariner Stadium in Seattle. We had our cameragraphers and noticed that we had this camera. We had a big antenna. This was 38 gigahertz. This is a millimeter wave. And we wanted to check the reach from the antenna to the cameragrapher. And also we wanted to measure latency, encode, decode, and seeing the video in live. And we were very surprised, very happy. We reached 83 milliseconds encode and decode at 60 megabit per second in 4K, 25 megabit per second on 1080p, and that allows us to match now, to go into business, to match studio cameras on fiber versus cameras. Okay, but we were not using a phone to do this. We were using something we introduced at NAB, which is a data transmitter. It looks like a phone, but it's not a phone. This is a very powerful multi-channel transmitter. It can do LTE, Wi-Fi, 4G, 5G, and it's designed to communicate to all of the Sony cameras, still photography as well as video cameras. It has a number of applications built in that automatically recognize the camera and pull out all of the videos over the transmission. Once again, it operates in sub-6, in millimeter wave, in private or public 5G. It has a USB-C connector that will receive the compressed data from the compressor. It also receives HDMI or RJ45. Very robust in terms of air cooling. Remember, if a unit becomes very hot, you start dropping data packets, and then the transmission fails. This is very robust for live operation. Then these are the use cases that we have for this unit, directly from the camera to the video switcher in the truck, communicating with the receiving decoder, which is the ME80. We can also go into the cloud. We have a number of software switchers in the cloud that can receive these signals. All right, this is our ecosystem. You have the cameras, whether that's cinematographic or broadcast camera. We go into the camera adapters for compression. We have USB-C that we connect to the data transmitter. Data transmitter goes to the production environment, okay? But there's something else. Bandwidth orchestration. What about if the receiving station can control the bandwidth and the quality and selection of the cameras that are on the transmitting side? This is bandwidth orchestration. We developed a software that's running on a Sony product called the Video iPad that is exposed to the 5G bandwidth using a network exposure function. And this software can see the bandwidth occupied by the different cameras riding on the 5G channel. And it can throttle the data rate from one camera to the other one. It can also send tally and return signals back to the camerographer. We tested this for the first time about 2 years ago during the coronation of King Charles. Back then in the UK, we had planned to use 4 cameras communicating over 5G. The broadcaster, you may imagine who they were, they said, no, we need more cameragraphers, we need more people. But the bandwidth of a 5G cell is about 150, 160 megabit per second. How do we can divide that highway in more little slices? Then is the concept of dynamic allocation. We opted for 8 cameras. The camera that is on air will receive the maximum bandwidth allocation for the maximum picture quality, tally, and return. And the other cameragraphers are going to be in standby. It's still beautiful picture, 18 megabits. But then we can talk to them and say, OK, now you are next. And the other camerographer that's on air is going to disappear, and you come in. This can be done in real time. This was shown at NAB. We had a technology suite, and we were demonstrating this, and also the control of the grading of the camera, because the cameragraphers are going to be exposed to different illumination. Therefore, we can control iris, gain, and the shading of the camera. All right, these are the use cases from a business viewpoint that we plan to cover in terms of wireless cameras and remote production. And last Thursday, we had the great opportunity to partner with T-Mobile and CBS to do the PGA Championship. That was a very important test for us because usually this is a very complex sporting event, they have been using fiber to connect the studio cameras to the trucks, but some of the holes are very, very long, and it's very expensive to throw that fiber. Also, some truck operators are using RF cameras, but the data rate is very low, and the quality is not really to the part to compete with the fiber cameras. Then this is we were given two holes, hole 13 and hole 18. This was a very challenging one. And we were using 38 gigahertz. This was millimeter wave from T-Mobile. Therefore, this was direct line of sight. And in preparation, we had our people just walking around and noticed that we had the data transmitter. This is what we thought would make sense to avoid it, because if you put your hands on the data transmitters, you're going to block the transmission. We thought this was good, and the reception was fine. We could reach about 800, 1,000 feet with very pristine picture quality. We were using 1080p. The whole production was 1080 progressive. Notice the big antenna at 38 gigahertz, and then we had a number of smaller receiving stations distributed around the trucks, right here. And once again, during the preparation, we were testing data rates, latencies. Can I match the latency that we have in the studio camera? And we were using FX6, you may know, and also Z280s. These are the two cameras that we had. But when the event came, then they decided, forget about that combination, and we're going to create a different structure. And then we created this pole, and then the camerographer has more freedom to move, and the data transmitter is always in constant communication with the transmitter. And they are not waterproof. Then in 2 days that were raining, we had to put the little plastic on top. And we were able to analyze the data transmission, both latency and data rates, how well the channel was behaving as we moved from hole to hole. And notice we settled around 22 megabits per second, and the latency was 31 milliseconds. Then it was perfectly matching the fiber cameras that we had. They had 3 fiber cameras in the course. Also notice the data transmitters are able to monitor the channel allocation. It has 2 SIMs inside. If we had 2 millimeter wave transmitters and one of them were to fail, it can switch immediately to the other millimeter wave. Anyway, another thing we discovered is CBS is using a company called, I think it's called Cyan View, that allows you to grade or shade the cameras remotely from the truck to the camera. But then you had to have a fiber connected to the camerographer. Well, what we did was we took the decoder of that control data and we transmitted the information via the return channel of 5G. Therefore, that data transmitter is not only sending the video, but it's receiving the control, the shading control to the camera. And it worked. Anyway, this picture shows, we wanted to check the top row is the 3 cameras, the fiber uncompressed, this of 1080p, these were HTC 3500. The ones in the middle are the 3 RPU7 adapters for 3 cameras. 2 of them were FX6, 1 of them was 280. And some of the unit pictures in the bottom, they were going actually on air directly from this communication. Well, just to conclude, it was a very successful experiment. I think it's now beyond the technology. What we need to figure out is the business, how to use this technology to create a 5G remote production. Thank you much. If you have any questions.
I think T-Mobile has rolled out standalone in most of the country at this point. SA, T-Mobile has. I don't think anyone
Yeah. Also, I just found out Amazon is using what they call it an independent private 5G, meaning they buy a slice of the bandwidth from a carrier, and they exclusively use that bandwidth internally. Then the carrier, I think it's T-Mobile, they have no control on how they use that bandwidth. Therefore, a lot of people are now beginning to do this private 5G communication.
So your 5G hardware, does that use Sony chips or is it Snapdragon?
Snapdragon.
X65?
That I don't know.
So when you're sectioning out the bandwidth for each camera, you're assigning that specific channel, and so it doesn't increase or decrease. So are you just then just assuming that even if the camera turns off, you still can't recapture that? There's no way to switch it?
We can, well, okay, very good question. We were not using the bandwidth allocation in this experiment. Had we used the bandwidth allocation, I could reuse that bandwidth of a camera and give it to other folks. But right now, it's basically, you have a highway and you have 3 lanes, point to point.
So is that automatic software switching you can do, or do you have to actually have somebody?
We have a controller. You can make it automatic. You can make it automated completely. But everywhere we are showing it, you have a person behind the workstations receiving signal from the switcher, so that the producer wants this camera, then you send the tally, the return signal. You need somebody that's controlling the workstation.
For the line of sight transmission, would you have any problems with the rain?
I'm sorry?
With the rain, with the weather, is that a factor?
Yes, yes. And more complicated. We wanted to use 22 megabits because that was absolutely indistinguishable from the studio. That will give us about 600 feet. If we were to drop it to 15 megabit, I could go to 1,000. But then you see a hair different between the studio and the shoulder mount. That's sort of a compromise. But it's very interesting to see how the channel behave distance versus data rate. But once again, I know there have been other presentations on 5G communication. This is very, very high picture quality with ultra low latency to be able to switch instantly. Not like you move your hand and 5 seconds later the hand moves on the other side. This is real-time transmission.
Is there any thought of collaboration for that ultra low latency? Because I noticed you use SRT as an example, and so SRT's in a whole bunch of different types of.
That's a tough one. I will have to go deeper into this, but the ultra low latency is achieved not only on the encoding portion. Remember, in a long GOP, in an interframe picture, the iframe, the interframe picture has a lot of data, and the predictive and bidirectional frame have smaller data. And that unevenness of the data rate is what produces the latency. We have managed to even out that unevenness, but also how you deploy that data into the transport mechanism is what is important to achieve the ultra low latency. And we have something called QoS, quality of service. It's a Sony owned proprietary for achieving that ultra low latency. We have been testing SRT, the same codec inside SRT, but we don't achieve the same latency. Now we are looking at 300 milliseconds, 400 milliseconds. And then now you have to worry about, I need the picture quality. The data rate, I don't want to pay money for that, and I need ultra low latency. That's what the market is demanding. If I go SRT, yes, it's open, but I may not achieve real-time operation.
You could use your own kind of UDP implementation where you serialize the data, you use UDP as a transport, and then you only subscribe to the couple of re-request packets you might need once in a while. But understanding that it's only 500 feet, 1,000 feet, and if you have line of sight, you probably don't need a whole lot of re-requests because, you know, you're right on top of the antenna.
It's more complicated than that. It's not that simple to. We have experimented on every possible change of UDP to achieve that, because we know SRT is very popular.
Yeah.
But we never say never, but so far we have not been able to drop it to the level of latency that we want.
Have you looked at wrist?
No, we won't touch wrist. No.
Not in the wrist.
We will not touch wrist with a 10-foot long pole. Any other question? Thank you much.
Thank you.
Digital Video Group will be hosting Integral Prime Tuesday, May 21st, 2024. This event will include workshops, networking, and hands-on product demonstrations. See the latest in broadcast and production solutions from over 40 of the top
Put it back to where it was.
manufacturers, including Sony, Ross Video, Panasonic, Hitachi, Canon, and many more. Seminars with guest speakers will be covering a number of topics ranging from 4K to video over IP. Register today at digitalvideogroup.com. Digital Video Group will be hosting Integral Prime Tuesday, May 21st, 2024. This event will include workshops, networking, and hands-on product demonstrations. See the latest in broadcast and production solutions from over 40 of the top manufacturers in our industry, including Sony, Ross Video, Panasonic, Hitachi, Canon, and many more. Seminars with guest speakers will be covering a number of topics ranging from 4K to